Namaskar. Hello everyone. Arvidi here and a very warm welcome to my YouTube channel. We are in our playlist Programming in C Sharp and this is the next video number 7. We'll be looking at the operators part 2. So in the previous video we've started with operators and we've covered some of the operators, I guess up to logical operators. In this we will be going ahead. So the next set of operators we have is bitwise operators. Now what exactly bitwise operators mean and what they do? So as the name suggests, bitwise operators. So they work on the binary bit pattern of the operands. Okay, we have bitwise AND, bitwise OR, bitwise XOR. Okay, we have one more. These all are binary, and one more which we have is complement. Okay, bitwise complement, which is getting the complement of a given operand. So it's a unary one. Okay, the tables go quite similar to what logical operators were. So again, bitwise AND, it's going to work on bit patterns, but only when both of them are 1, it will be 1. Bitwise OR, if either of them is 1, it will be 1. Bitwise XOR is like binary addition. So if both of them are equal, like 1 1 or 0 0, then the answer would be 0. If both of them are unequal, like 0 1 or 1 0, then the answer would be 1. Okay, maybe I'll use the next slide for giving you the table of bitwise XOR specifically, because AND and OR we have already done. Okay, so as I said, the table, so A, B, A XOR B. Okay, so 0 0 0 1 1 0 1 1. Whenever they are equal, they are same, then the answer is 0. And if they are different, then the answer is 1. That's XOR. Okay, now how exactly these operations can be carried out? So let us take some examples. I'll be taking a rough examples now. Suppose my A is, let's say, 23 and B is 36. Okay, ideally it has to be represented into 4 bytes, that is 32 bits, because int here represents 4 bytes of memory. But for our convenience, we'll be looking at simple 8 bits. So 23 is 16 plus 8 is not required, plus 7. Okay, so this is your 23. 16 plus 7. 36 is 32 plus 4, 32 plus 4. So this is what we have. So let me again put it. This is 23, this is 36. Again, if you are getting confused, I'll help you with this. 1 2 4 8 16 32. Okay, nothing is 0 here, and ideally we have some more digits, some more bits, So to start with, let us do AND. Now what AND is? 1 0 0 1 0 0 1 1 1 0 0 0 0 1 0 0 0 1 0. So if you see, it's only 1 here, so the answer is 4. Whereas if I go for OR, 1 0 1 1 0 1 1 1 1 0 0 0 1 0 1 1 0 1. So you can see everything's there, everything is 63, but you don't have 8. So if you check, it will be 55. If you want to cross check, 32 plus 16 48 plus 4 52 plus 2 54 plus 1 55. Let us look at the XOR. 1 0 1 1 0 1 1 1 0 0 0 0 1 0 1 1 0 1. So now we don't have 12, so it's going to be 51. Let's check. 32 plus 16 48 plus 250 plus 1 51. That's how the operations can be carried out, and these are the bitwise operators. Okay, so they will be working on the bit patterns of the given operands, the binary patterns. Okay, let's go ahead with next. So next we have bitwise shift operators. They also work on the binary bit pattern, but the style is obviously different. So we have left shift, right shift, unsigned right shift. Okay, when it is right shift, we are obviously jumbling with the signed bit, and that's the reason the normal and the unsigned we have two variations. Left shift, it doesn't matter. So what does it do is it actually tries to shift the bits by the number of shifts as mentioned after the operand. Let's see how exactly we can use this. So suppose let's say we are going for left shift first. Okay, we are going to do left shift. So let us take A as 11. Okay, now what I'm doing is 11 is what? This is 11. Let me just put 4 more bits, so it is 8 bits. I am again saying that ideally we should go for int, so that is 32 bits, but this is just for the convenience. So now if I do this, A is equal to A, then left shift by 1. So number of shifts are 1. Okay, it is going to get shifted to the left. So left, if it is getting shifted to the left, this is what is going to happen. Okay, this 0 is going to fall down, and when we have a space here, 0 will be added. Okay, so you can see because of that all the powers got shifted. Now this is 1, 2, 4, 8, 16. So 16 plus 4, 20 plus 1, 22. So the answer here is 22. So what you've understood by this, if I do left shift by 1 bit, it is multiply by 2. And we can very well apply the formula. If I do it by 2 bits, multiply by 4, 3 bits, multiply by 8. So if I do it by k bits, multiply by 2 raised to k. Okay, let us look at right shift. Okay, so suppose I have A as, let's say 27. Okay, so what is 27? 16 plus 11. So this is 27. We've got one more. Yes. Now actually the last bit MSB here is the sign bit. Because it's positive, it's going to be 0. It will have a difference when there is a negative number. Okay, in this video we currently are not going to get into negative because that will require a lot of extra explanation, but I'll be able to show you just with the example that what is the difference between a normal right shift and a unsigned one. So now what we have to do is a right shift by 1. This is a normal right shift, that is a signed one. Okay, so what happens is here it has to be shifted to the right. Okay, so this obviously will fall down, and now here can you see that sign bit is getting shifted. So what signed right shift will do is, if the sign bit is 0, which is getting shifted, it will pad the extra bit also as 0. If the sign bit is 1, it will pad it as 1. Currently the sign bit was 0 because the number was positive, so I'll be padding it by 1. Okay, let us first finish this, then I'll explain you what is the difference between normal right shift and unsigned right shift. So now you see again the powers are now decreased. So it is 1, 2, 4, 8. 8 plus 4, 12. 12 plus 1, 13. That's the answer. So 27 divided by 2, if you know, it's 13. So right shift, if you shift it by 1 bit, it is divide by 2. And the same way you can find the other formula. That is k bits would be divided by 2 raised to k. Okay, now get it clearly. If it's a normal right shift, that is signed right shift, while shifting, it checks what is the sign bit. So even if you shift the sign bit, the padding of whatever number of zeros, currently so we are shifting it only by 1. Suppose you are shifting it by 2 or by 3. Those many empty places are there which we have to pad new digit. So whether the new digit would be 0 or 1, that depends on the original sign bit. So original sign bit agar 1 hai, so the padded digits would be 1. Agar original digit 0 hai, so it will be 0. Now this is normal signed right shift. What is unsigned right shift? As the name suggests, unsigned right shift. So it will not consider signed bit. It is not just a normal digit. So irrespective of the sign bit, whenever padding is required, it will be padded with 0. Okay. So generally, when we are working with negative numbers and we are expected that the sign has to be preserved, then a signed right shift, which is a normal this, has to be used. If at all you go for an unsigned right shift, don't expect the sign to be preserved, because it is anyway saying unsigned and the symbol is also kept different. Okay. Left shift, signed and unsigned, it doesn't matter. So it's a normal two characters wala symbol, whereas right shift 2 character wala symbol represents signed right shift, get it clearly, and 3 represents unsigned. So for right shift normal, that is signed, whether 0 will be padded or 1 will be padded depends on the original sign bit. Whereas in unsigned right shift, by default 0 will be padded for the shifted place or for the empty place. Okay, I've tried my best to explain this properly. Still, try to understand. You can pause the video, go back, listen to what I said, try to do it yourself. If you have any doubts, you can very well put it in the comments box. Okay. For negative numbers, I have not shown here. Maybe I'll see if I can make a separate video where we are going to deal with negative numbers, and I'll show you how they can be represented and then how we can do the shifting of that. Okay, if you are very curious at the same time, as I have not yet done the video for C#, you can go to my C programming playlist, where you will see there's one video which clearly shows how the negative numbers are represented in memory and how do we do shifting of that and so on. So that will really help you a lot. Okay, so let's go ahead. Assignment operator, they are used to assign a value from right to left. Okay, so general form of assignment operator is something like this: a is equal to 50. So this is a value which is on the right and it gets assigned to the variable on the left. Now what is L value and what is R value? This L value stands for location value. Generally that is given by a variable, whereas R value stands for read value, which could be given by a variable as well as by a constant, because we want some value to be read and used. So your L value can either be on left or right, but your R value has to be on right. So it is only possible to be kept on right. Okay, because see, I can do A equal to 50. Yes. Can I do B equal to A? Yes. So you can see my L value, which is a variable, is also possible to be on the right side. But I can't say 50 equal to A. I can't keep my R value on the left. On the left side, we have to have L value. On the right side, we can either have L value or we can have R value. Now what is shortcut assignment? Okay, shortcut assignment is when I combine the assignment operator with some other operation. Like for example, if I want to do A is equal to A plus B, I can do it like A plus equal to B. This is shortcut assignment. Okay, I can have B multiply by equal to 5, that is B equal to B into 5. Okay, like this. So plus equal to, minus equal to, multiply equal to, divide equal to, mod equal to, and equal to, or equal to, so on. All these are nothing but considered to be shortcut assignment operators. Okay, so that is about the assignment operator. We've learned very important concepts here, that is L value and R value. Generally, the R value, which is supposedly be on the right, gets assigned to the L value. But be clear that my L value can also be present on the left if I have, on the right. So if I have L value on the right, it is not getting used for storing, but it is getting used for reading. So when I say B equal to A, B being on the left, it is used for storing. What to store? Whatever value will be given by A will be stored in B. Clear? Okay, so let's look at the next conditional operator. So it's the only ternary operator given by your C# also. This is the basic syntax. It's a single line alternative to if else. So it's like check the condition. If the condition is true, then you will execute expression 1. If the condition is false, then you will be executing expression 2. So the value of the full expression would be the value of expression 1 if the condition is true, or else it will be value of expression 2. Okay, let us look at the example. So if I want to find the maximum out of 2, so it will be A greater than B, then A, else B. Okay, I repeat. So if A greater than B, if it is true, it will take up A value and that will be a maximum. If this is false, it will take up B. Okay, you can try to correlate this. I'll just take one more, a bit more, not confusing as such, but more challenging, and I'll leave it to you for getting it very clear by practice. So if I want to find max out of 3, I'll be using the nested conditional operators. How do I get max out of 3? I would say A greater than B question mark, A greater than C question mark A colon C colon B greater than C question mark B colon C. Okay, now it looks very confusing. I'll just help you. This is the outer one. This, then this is expression 1 and this is expression 2. So this is the outer one. Okay, if this is true, it's going to go to this one. If this is false, it's going to go to this one. See, if A greater than B, then I should compare A with C, which is done here. If A greater than B is false, that means B is greater, then I should compare B with C, and that's going to give me the final answer. Okay, so if A greater than B is true, compare with A and C. If A is greater than C also, A is greatest, otherwise C is greatest. Whereas if A greater than B is false, that means out of this two, B is greater, then if go to this expression directly as per the rule. If B is greater than C, then B will be greatest, but if this is also false, then C will be again greatest. It's a wonderful example, and it is actually using the nesting of conditional operator. Okay, so nesting of conditional operator is done with this particular example. Okay, so it's one of the important operator. We have if else, so we generally don't use it very widely, but if you want a single line alternative where it has to be done in a crisp way, conditional operator is a good choice. Okay, so that's it as far as the operators are concerned. Of part 2, obviously we have one more part coming up later on where you will be looking at some miscellaneous operators, but here we've done bitwise operators. We had seen how normal bitwise, that is ANDing, ORing and all these things are being done. Then we had seen bitwise shift operators. Again, bitwise shift has got right shift, left shift, and in right we have unsigned, signed and so on. Then we had seen assignment operator with a very important concept of L value and R value. And then we had finally seen the ternary operator, that is conditional operator. Okay, so again a very informative video with a lot of operators being very well explained with example. Please go through the video properly again, revise it, prepare it, and if at all you have any doubts, you can put it in the comment box. We'll be having one more video of operator, as I said, in the third part. We'll try to introduce more operators. But as far as the current video, that's it. Thanks a lot and a very happy learning.